So what's going on here? I'm going to be getting my high mesh. These are all my high resolution meshes right here. I'm getting all of them right here. And then what I'm doing is to getting the boot roof low, which is the first part that we did. And I'm setting a mask. I'm creating a mask. This mask looks something like this. Let me show you. Remember, we are adding some points. So these masks are in the points itself. If you were to look for this is the mask. What I'm doing is to just removing the points which are less of a threshold on the mask. These are the roofs that is low, and I'm merging these to get together. You'll see these are merged. I'm transferring the attribute copy from this guy, which is way lower, because this comes first. So in order for me to follow this, I need to explain what's going on right here. So this is like the key part of the simulation, how the things are going to be exploding, let's say. We have this wood roof low, the roof is low, everything the low is it here. And I'm going to be determining how this is going to be, well, exploding. Just ignore this error, which is not in the final render. So, and also the windshields proxy. This is everything below. But I separated the windshields because I wanted to have different velocities applied to it. So what I'm doing here is saying, hey, get me the point, which is this one. And what you are going to be doing is calculating a vector, which is the position minus the point, plus a distance from 0 to 4, normalized to 1 to 0 with a multiplier. How this looks? Well, it looks something like this. This is how it looks. If I were to change the point, it will just move differently. So these are the forces which are going to be transferred then. I'm going to do the same for all of these guys. In this case, I'm also going to be doing the same for the W. The W is just the rotation. I'm going to be adding this. This is the direction I want them to be rotating. The same here, also here. And finally, I'm masking the velocity with the same mask. So you can see this is the mask I have. There are some places where I don't want to have velocity, so I'm just, well, sorry. So this is the mask I'm creating. So where I have a mask is probably where I'm going to be having, is probably where I'm going to be masking this later on, because I'm adding a little bit of a velocity coolness. So now everything has a velocity. So with the mask, I'm just going to be eradicating these velocities, which I don't want. I'm going to be doing the same for the windows. This is exactly the same workflow, exactly the same. And then I'm just basically fitting my velocities from 0 to 1 based on the mask. As you can see, I'm just killing the velocities. Also, everything that has more velocity than 0 is going to be active, and everything else is going to be inactive. I'm going to be removing all these guys. This is the proxy to constraints, and these are the points. I'm just basically getting a bunch of points. The group 2 is also going to be active, but it wasn't active beforehand. Then the wood planks W, if it's more than this, it's also going to be active. And finally, I'm just selecting a bunch of points which were not selected previously, which I don't know where they are exactly, but probably some points that were in need for them to be active. And I'm just saying, hey, you're going to have velocity set to this. It's probably some windows. I'm not so sure. Finally, I'm going to multiply the W by 4 because I said, hey, I want more rotation. But before doing this, which are the constraints, this is the velocities, these are the constraints. Before going to simulation, we're going to be looking at the constraints. So how these are done? Well, we already explained. I'm just transferring the active, which is created here, as shown before. Everything that has velocity is going to be here. I'm going to be promoting this to primitive and going to be connecting these guys based on the name original. So basically, everything where there is a piece is going to be connected between the roof tiles and these pieces because they have different name originals. I'm going to be removing everything that's just not active, because if I don't remove it, I might have the possibility that a piece is not moving. It will stay stationary. Everything is going to be called glue tile roof, because this is going to be a glue. I'm going to be doing a similar setup here, the roof tiles low, where I'm going to be creating or deleting everything that is inactive. I'm going to add in all the pieces. I'm going to create another mask. I'm going to connect the adjacent pieces. This is a very nice way of doing it. I'm going to be removing based on the mask. So these are the constraints I'm going to be keeping. Then I'm going to be recalling these to glue roof tiles. Glue roof tiles, and I'm going to just be deleting certain places where I want them to be separated. Yes, you can see right here, because I don't want these to be joined together. Also, yeah, nothing else. In this case, this is the roof proxy. The same trick. I'm going to transfer the active. I'm going to connect adjacent pieces. I'm going to remove everything that's inactive. I'm going to do the same but a glue wall and blast what I don't need. On walls, mirador, exactly the same trick. Connect adjacent pieces, remove what I don't have active, and boom. For the planks, which are these ones, I'm going to this is going to be different. It's going to be a little bit different. I'm going to use a constrainter. The constrainter, what it's doing in this case, I'm going to be showing is like a bunch of operations. And in this case, I'm selecting the wood. As you can see, it's a bunch of things, which is basically just compacting this into a single node. If we dive in and we go into the wood, which is this one, I'm doing two things. Firstly, setting everything to a pack and adding a bunch of points. These points are going to be the clusters. So I believe per cluster, yes, per cluster, I'm going to be connecting the pieces with a clean. I'm going to be calling this, and as always, I'm going to add a color. So this is going to be the cluster. It's what's going to be merging pieces strongly between each other. On another section, I'm going to be promoting the cluster. I'm going to be unpacking this, promoting, doing a connectivity so I can have all the different pieces and connecting all of them based on the cluster. Again, this is between points and this is between the edges, so it's different. Then I'm going to be calling this as the hard, because this is going to be hard constraints, and these are going to be glue constraints. And that's all I'm doing. This is for the flexibility, and this is for the strength, for the glue. And this is for other things which I'm not really using. This is for twist constraints, and this is for regular glue constraints. But that's all I'm doing here for the wood. This is how it looks. If I merge everything together, we'll see I have a bunch of constraints. Very nice. I'm going to be cleaning this. I'm going to add a group because I'm going to be separating this or adding just more strengths because I didn't want this part to be breaking so much. It appears to be. I'm going to be deleting everything that I don't need. I'm going to be time shifting this to frame 101 because some of these things are time dependent. Well, going into my simulation, all I'm doing here is to be calling all the constraints, because remember, guys, that I added different names to the different type of constraints. So if I call this glue roof tiles roof, you will see, I just turn this off, you will see these are some part of this is one type of constraint. This is another constraint. So I'm adding glues, I'm adding soft bullet constraints. The soft bullet is for the tiles. They're going to be merged, but they are going to be able to bend a little bit between each other. The glue wall is the blue one, if I'm not mistaken. Yes, it's just a glue. This is another glue for the actual shape of these. I don't know how to call it, where you have a window. This is for the or yeah, this is for the connections. This is for the planks basically. This is the glue, this is the heart. This is what's going to make it a little bit bendy, similar to the bullets of constraint, but hard. So they have different properties, but they are usually used for the same. The hard W doesn't break unless you have like a function, which is going to be added later on. So this is the RBD. These are the constraints, and this is it's simply the proxy which we injected from here. And these were the proxy to constraints, and these are the actual constraints. So we merge both of these things together, and this is what we have with a constraint network, which is referring to the constraint null on top. And this is just the RBD, which is connected on the first place. Now you would think, what's this subsolver doing? Well, this subsolver is actually breaking some things. Let's go just a couple of frames forwards. And that subsolver is actually breaking some of the constraints which cannot be broken otherwise. So let's just go here. You will see this is what's going on with the forces which were applied beforehand. I'm actually liking this simulation a lot. And you will see I only have this, where I'm calling the glue roof tiles, and I'm saying, hey, if the angle is bigger than this threshold, just break. Anything else is not going to be breaking. So I'm calling this glue roof tiles, so which is glue roof tiles. See, I ended up choosing a soft body constraint, even though this is called glue. It is not glue, it's a soft, which is basically this, which is basically merging the roof tiles, and it's creating that like these clusters. Otherwise, I wouldn't be having this cluster. It's not so good looking without it. And that's about it. There is a pop force, wind. So where the name is called wind for the windshield, as you can see here. What I'm doing is to just reducing the gravity, and well, everything that's not wind is having normal gravity, so they don't fall so much. But the simulation is pretty simple. It's just that I'm retiming then, so I can have like a slow motion effect. But this is what's going on. One thing that I forgot is to retime this, because I should have not retime this, but I should have lowered the velocity for the render, because the motion blur got strange there. But it looks good anyways. Then grabbing all this high resolution mesh which was created, and I'm going to transform the pieces. You will see it looks quite nice. This, remember, was calculated with the low res, so it's actually pretty fast. Now that I have all things, I can add the shards. So the shards is a different setup, which is like a simulation on top of the simulation. If I merge these two guys together, I have the RBD plus the shard, which is just a copy the points. It's like adding a lot of detail, as you can see, which is very nice. This is from the camera, and this is the RBD. I'm just setting the names to the name original too, so everything is kept as usual when I import it to Solaris. So how these charts were made, once I save this, I'm going to just grab the low and transform everything, but I'm going to be separating the charts. I'm going to be removing everything that's just not as fast as I want. If the velocity is less than this, then it's going to be removed. See that there are some pieces that are just stationary. And with the resource, what's going on here is that I'm basically detecting where they break, and I'm removing everything whose point number is less than this threshold. Basically, I'm just removing over time, and I'm adding a W, which is being multiplied by a random number to 4. And the left is going to be 100. And then I'm removing again. I decide to remove everything from one frame to another. So I could just remove this. And then I'm adding a new orient. Random is like a random orient. And what's going on here is that I'm actually creating a pop solver with these guys. I'm going to just remove this. Basically, I'm birthing these points over time. Look how fast this looks with a simple point drag and a pop spin, which is spinning everything based on these axes. Remember, I had a different orientation, so everything is going to be rotating differently. And that's about it. These are the points which I need. And then I'm going to add a different variant. I'm going to be casting this into an integer. I'm going to transform it into scale, so I can have very low big pieces and a lot of small pieces. I'm going to be changing the color to white. I'm going to be saving these shards. Then I'm going to be selecting a couple of pieces. I'm going to be then shifting this. I'm going to be unpacking, setting the names, and match sizing this to the 0 and assembling this. So when I copy and paste these shards, it's going to be selecting a different shard per point, which looks very, very cool. And that's my shards. If I merge both of these guys together, this is what I get. Well, let's continue to the rocks. This is a small setup, but it's very fun to do. I'm creating a box and a grid and a scatter and a line and a copy to points. These are the rocks which will be sent forwards in the actual animation. Let me show you this. Yes, this is with the camera, and let me show you the Titan. This is what happens. The Titan comes and it should be exploding. So the scatter and align is just for the orientation. As you can see, I can move this and orient them as I want. This is the set names, and I'm also subdividing this, adding a mountain symbol. So in this case, what's going on is the same trick of the velocity and the point subtraction based on the distance with a lot of W. This was actually copy and pasted from my RBD setup. And if I go inside here, what's going on is pretty much nothing. I'm just pasting the rocks and, well, doing absolutely nothing. I'm controlling everything from outside. And this is what's going on. Just a point and a bunch of rotations, and that's it. Then I'm adding this and frustrating what I don't want, apparently. Oh, I'm just grouping, okay. Then with the solver, what I'm doing here is doing a masking, basically clamping the mask for which I got from this guy here. Basically, everything that's outside the frustum will get a mask. Let me show you. See, there is a mask that's being transformed to red. And with this solver, I'm basically adding the mask over time and clamping it to 1. So it's basically saved into the points. Then I'm deleting everything whose mask is less than a certain value. And I'm time shifting this to the final frame. And I'm just basically finding the value name. If the name is equals to 0, then I'm going to be removing. So since I only have these points here, I'm just going to be removing what I'm not seeing in the camera. This is a good trick to make everything a little bit more optimized. This is the retain points in slow motion, and this is the unpacked version. What I'm doing here is to these points just transform this with a simple volume noise into higher resolution meshes. Look how nice they look. It's basically a BDB from polygons with some flow noise added to the position, like so. There's nothing else, and just converted it into a BDB. Then I'm saving the rest position, assembling this with the retain points, which are those. I'm just going to copy and paste this guy here. See, it follows, and this is all I need. This is the transformer and the outbix. Going forwards, this is the collider, which is basically a transformation. This is unpacked and poly-reduced, so it's easier to calculate. Way easier to calculate, in fact, because this is very taxing for the computer. Otherwise, you will see this is the geometry and this is the point deformation. And then grabbing the transformation, converting this into polygons, adding a scatter, and interpolating this based on the points, which these are the points. And what I'm doing here is to just add IDs. Oh, one thing, remember that this has to have a source prim and source prim UV, so the attribute interpolate works with the same things. These two guys are the same, so it could be something like that instead. So it's easier to understand. It's going to be interpolating points based on what I need. So this is my attribute ID, and I'm doing shifting this and adding a mask right here. I could have added this mask over here, but I wanted to do it here. So I'm just, I just have some masks, which I'm going to be popping to the points. I'm going to be trailing this. I'm going to be trailing this with, again, with the compute velocity, and this is the position. I'm going to be adding this, so I can have like a trail right here. I'm going to be resampling this, adding a point velocities, curl, and then just removing everything whose velocity is less than, well, everything, no, I'm going to be masking and fitting based on the velocity from 0 to 10 to 0 to 1, and this mask is going to be used as a remove function. So only at the beginning, where there is a bunch of movement, the mask is going to be working. And my velocity is going to be multiplied by the mask 2. These are the two different masks, remember. Then, based on a random point, I'm going to be removing it upon a time. So I only want to have the points here, and then I don't want anything. And the W is the same trick of rotating everything with an orient here. So what's going to happen here? Basically, I'm going to be emitting points, and then I'm going to be animating. And inside here, what's going on is, firstly, I have this pop object, and then I have this pop source, which is just emitting from the source from the first input, and I'm just frustum based on the camera. So if it goes outside the camera, it should be deleted. Then I'm advecting by some volumes, which is, these are the advect particles. So basically, it's following the rocks and rasterizing the velocity from these rocks. That's the only thing I'm doing. Anyways, then I'm doing a little bit of drag and spinning this by 40. That's about it. And I'm also changing the scale based on this mask. So there are a bunch of small rocks and little big ones. And then I'm just doing these rocks, which are going to be scattered all over the place. And it looks something like this. So from camera with the motion blur, it's going to look something like that. Also, I'm going to change the rocks so it's easier to load into Solaris. And then I'm going to merge these two guys together. And this is what I get. This is then going to be transformed in Solaris. So how were the smokes from the houses created? Firstly, I created 4 different boxes because I found 4 different simulations. This is based upon this maximum class, which is 3. So we should have a look at the file cache, which also has the wedge count to 4 and a wedge per point. So if I were to train statics, I'm going to have 4 different simulations. This wedge is going to be plugged into this guy, which is then going to be grabbing the low, is going to be blasting what I need, and it's going to be transformed based on points. And this is where I'm going to be getting the debris source, doing the noise for the dance, CT, which is this one. This noise, well, it's just a simple noise. This is the velocity, which I'm going to be adding to the points for the rasterization, which is this one. This is the name, which I'm going to be changing for the temperature, because I want a little bit of temperature to adjust some things in the solver. And once I have this, I'm going to add a little bit of distortion to the smoke itself, of course, to the sourcing. It's just a little bit, not much. It's just a simple flow noise, turbulent noise. And then with this Axiom solver, what I'm going to be doing is sourcing this with less velocity, and then I'm just adding a lot of cooling rate with this disturbance, which is, well, I'm not changing anything but this for the temperature for the disturbance number 3, and everything else is pretty much as the old trick I told you: big scale, medium scale, and an even bigger scale, so 0.3, 0.2, 0.1. And here is the, or is I'm not mistaken, yeah, it's double the original. A lot of disturbance 3 because it was using the control field, so I just needed a lot, otherwise I wasn't getting much. And then I'm also, if I'm not mistaken, wait a second, I'm also animating this time scale, and this time scale is getting from the red time on the RBD, the one I used before, remember, for the slow motion of the RBD. And if I were to show you this, I can show you one per house. Okay, in this case I'm showing you everything, but I can show you. This is wedge number 1. We're going to do this in static and just go one by one. So these are all the wedges. It's a really nice way to have plenty of simulations with a simple trick of having a max class and wedging everything so I can blast what I need right here. And the setup is pretty small, but it's actually very clever. And finally, for the smoke round, I have a little bigger setup where I'm having the explosion center, and I'm using the good old paraburst explosion, which is this one. This is what I got, and I blasted a part which I didn't like, which is this one. And then I just changed the P scale and the velocity, and also the position was added to the velocity. This was useful in case I had like turbulent noise or something. Then I fruited this based on the camera, and I added this to a rasterize. On the other side, what I'm getting is the trail source. This is like another source, as you can see, is for the small rocks right here. What I did is to just copy and paste what I had, then split everything and do an add with a simple trail. The same for the unpack and the trail. This is a little bit more taxing for the computer, but it looks something like this, where I'm adding these values and blasting based on the camera and rasterizing everything. If I have all things together, and I have an Axiom shape, one for the ground and one for the frustum, with some settings like this one. Let me just turn this off. With I believe it's the same one except for the disturbance 3 and the lack of turbulence, because everything is just the same. The time scale is also being animated with the RBD, so it follows the same time scale. The trick is the same: 0.1, 0.05, and 0.025. As you can see, I'm basically dividing by 2 each time I go forwards. And this is how it looks. If I go forwards to this frame, it's just loading, and from the camera, you will see I have small trains here, but also big trains right there. Also, one good thing to keep in mind, I'm not exporting the temperature and the settings. I'm using this so I can have like better shape overall. I'm using CUDA and this division size with 4 substeps.